Hello, and welcome to the lecture on 3.7. Today we're going to talk about polynomial and rational inequalities. We've done this topic before, so this entire section might be an overview of what we've already learned. Polynomial inequalities have the form p of x is greater than or equal to 0, p of x is less than or equal to 0, p of x is greater than 0, or p of x is less than 0. Solving polynomial inequalities. 1. Move all terms to one side. 2. Factor the polynomial. 3. Graph all zeros on a number line. 4. Determine the sign of the polynomial on each interval. 5. Solve by finding the intervals that satisfy the inequality. Let's go ahead and jump straight into an example, because I know we've done this before. Solve the inequality. 2x cubed minus x squared is less than 9 minus 18x. All right, so first step, get everything on one side. 2x cubed minus x squared minus or plus 18x minus 9 is less than 0. Then what we want to do is factor. So I'm going to group the first two terms and the last two terms and factor out what I can. This is generally how we factor polynomials in the book that are degree 3. Factor an x squared out, we're left with 2x minus 1, and we can factor a 9 out, and we're left with 2x minus 1. Then we can factor the 2x minus 1 out, and we're left with x squared plus 9 times 2x minus 1 is less than 0. Now I will note that this does not actually factor anymore. That's it. So the only solution when it's equal to 0, not less than 0, but equal to 0 would be at 1/2. So we take that, the 0 of the polynomial, and we plot all of the zeros on a number line. 1/2 is the only 0, so that's the only one we need to plot. And then on each interval, we look at each of the corresponding factors and their signs. So on this interval, we're talking about when x is less than 1/2. And then on the interval to the right of 1/2, x is greater than 1/2. So if we are to the left of 1/2, say 0, 0 minus 1 is negative, so this first term is negative. 0 squared plus 9 is positive. I will note that x squared plus 9 is always positive. But x squared plus 9 times 2x minus 1 would be a negative number times a positive number, so that gives us a negative number. So on the interval x is less than 1/2, the entire polynomial is negative. Now let's look when x is greater than 1/2. So if x is bigger than 1/2, say 1, we have 2 times 1 minus 1, which is going to be positive. Plug in 1, you get 1 squared plus 9, it's 10, also positive. And then for the entire polynomial, x squared plus 9 times 2x minus 1, we would have a positive number times a positive number on this interval. Give us a positive. So our function, our polynomial, is negative when we're to the left of 1/2, so x is less than 1/2. And we're positive when x is greater than 1/2. So we go back to here, our inequality, and we say, all right, which of these signs satisfy this inequality? When x is less than 1/2, we have a negative value. Is a negative value less than 0? Yes. So every value within this region where x is less than 1/2 will be a solution to this inequality. And negative infinity all the way up to 1/2 is a part of the solution, right? Because any x value to the left of 1/2, i.e. less than 1/2, will yield a negative number for our polynomial. And we're looking for when our polynomial is less than 0, which is describing what a negative number is. Right, now let's check when x is greater than 1/2. When x is greater than 1/2, we have a positive value. So our polynomial is positive on the interval 1/2 to infinity. Does a positive number satisfy this inequality? So if this polynomial is positive, we would ask ourselves, is a positive number less than 0? No, positive numbers are greater than 0. So this interval is not a part of the solution set. So our entire solution set is negative infinity to 1/2. I want you to try one now. Solve the inequality. X plus 5 quantity squared times x plus 3 times x minus 1 is greater than 0. Next thing I want to talk about is rational inequalities. Let r of x equal b of x divided by q of x. And we do a definition here. Remember, just r of x is a rational function. The cut points of R are the values of x at which p of x is equal to 0 or q of x is equal to 0. Note, to solve a rational inequality, we use test points between the cut points. Now, what I'm going to do next is just give you a guideline on how to solve these types of problems. Steps for solving rational inequalities. Move all terms to one side, rewrite the inequality so that all non-zero terms appear on one side of the inequality symbol. Bring all quotients to a common denominator. 2. Back to the numerator and denominator, then find the cut points. 3. Find the intervals between the cut points and make a table of signs of each factor on each interval. 4. Solve. Determine the intervals that satisfy the inequality. As I said before, we've done this multiple times before, so I'm going to do an example here and show you how to do this. I want to ask a question after I finish writing this. 1 over x plus 1 over x plus 1 is less than or equal to 2 over x plus 2. Step 1 is to get everything on one side. Why then can we not just multiply x plus 2 to both sides and the denominators over here, x times x plus 1 to both sides? Why can we not do that? And yes, we cannot do that. It will not give us a proper result. Okay, so pause the video and think about that for a second. The reason we can't do that is because we don't know the sign of this, right? Because x varies through the entire domain. So suppose, for instance, that x is equal to -3, right? Then we would have 2 divided by a -1 here, and we would be multiplying both sides by a negative number. So we would have to change the sign. But remember, x varies. So if x is equal to, say, 4, instead of -3, x is equal to 4, then we'd have 4 plus 2 is 6. And we'd be multiplying 6. So we wouldn't change the sign. So which is it? Do we change the sign or do we not change the sign? So this discrepancy is why we can't multiply both sides by the denominators. We actually have to move everything over to one side, combine them by finding a common denominator, and then run through the chart of signs. So first step is to move the 2 divided by x plus 2 to the left. And I'm going to find a common denominator between these two as well, which is going to be x times x plus 1. So multiply this one by x plus 1, top and bottom, because x plus 1 is missing in the common denominator. We multiply this by x, top and bottom, because x is missing in the common denominator for this one. So over here, we would have x plus 1 plus x divided by x times x plus 1. That would be combining these two. Minus 2 divided by x plus 2 is less than or equal to 0. Okay, now we have another sum of fractions. We have a fraction here and a fraction here. We need to find a common denominator between these two now. And that common denominator will be x times x plus 1 times x plus 2. So this here is, of course, 2x plus 1, because we combine the like terms, which would be x's. Now, this fraction is missing x plus 2 in the common denominator. So I need to multiply by x plus 2 top and bottom. And this fraction is missing x times x plus 1 top and bottom. So combining these, we would have x plus 2 times 2x plus 1 minus 2x times x plus 1. This is all less than or equal to 0. Okay. Now we need to multiply this all out so we can combine like terms and then refactor. So right now, this is not in a factored form because it's not all multiplied together. We have the subtraction. So we have to FOIL these two out, and we have to distribute the 2x in this one. And then we subtract, and then we can refactor. So here, we would end up with 2x squared multiplying the... I'm going to FOIL these out first. We get 2x squared plus x plus 4x plus 2 minus, and now I'm going to distribute my 2x here. So if we group these two, we can distribute this to both of these. So 2x times x is 2x squared, and 2x times 1 is plus 2x. Now, do not forget to put the second one in parentheses. Why do we need to do that? We need to do that because we have a subtraction on top. So the subtraction is actually going to distribute to both of these. I could have distributed it with the 2x, but I didn't, so we need to make sure that we still distribute it. So here, I will have 2x squared plus 5x, combining like terms, x and 4x, minus 2x squared minus 2x, all over x times x plus 1 times x plus 2 is less than or equal to 0. Now combining like terms, we have a 2x squared minus a 2x squared. And we have a 5x minus a 2x. So that gives us a 3x plus 2 divided by x times x plus 1 times x plus is all less than. So this is my the factored form of the rational expression with our inequality, within our inequality. So we need to figure out what our cut points are now. The cut points are what make the x values that make the numerator 0 or make the denominator 0. So making the numerator 0, we look for this cut point. This will be x is equal to negative 2/3. And then we look for the values making the denominator equal to 0. So we would have x times x plus 1 times x plus 2 is equal to 0. And we would have x is equal to 0, x is equal to negative 1, and x is equal to negative. These are all really close together. So these are my 4 cut points. So the next point, or the next step in the solving process, is to build a chart. And this we have done before, several times. So here's my number line. And we're going to plot each of these. We have negative 2, negative 1, negative 2/3, and 0. And no, they don't need to be evenly spaced out or even spaced based on their respective values. I just need space to write the interval. So for instance here, our interval is that x is less than negative 2. In between negative 2 and negative 1, we have a negative 2 is less than x, and x is less than negative 1. And between -1 and -2/3 would be -1 is less than x is less than -2/3. These do need to be written in ascending order. -2 is my smallest number, -1 is my second smallest, third smallest, and of course my largest. And this should be obvious because we're plotting them on a number line. And the number line is always in increasing order. And then, of course, here we have -2/3 is less than x is less than 0, and then x is greater than 0 here. So these are our intervals. And we need to write our factors here on the side. So we have 3x plus 2, that's our numerator, and then each of the factors here, x plus 1, and x plus 2. And then our entire quotient will go here. I'm just going to write it as p of x. And remember, p of x is equal to 3x plus 2 divided by x times x plus 1 times x plus 2. So now we check the sign when we plug in a test point on each interval. So on the interval x is less than -2, we use a test point, -10. So if we plug in a -10, this value is negative. We get a negative here. Plug in a -10, we have a negative here. Plug in a -10 and a -10, we get a negative and a negative. So p of x is going to be 3x plus 2, so a negative number, divided by x times x plus 1 times x plus 2. So a negative number divided by a negative times a negative times a negative. So if p of x will look like this. We have a negative divided by a negative times a negative times a negative. I don't care what the values are. I care about the sign. So overall, the numerator is negative and the denominator is negative, so p of x is positive. Now between -2 and -1, so this would be -3/2, say, something like that. -3/2 will make this negative. If you plug it in, you'll have 9/2 plus 2, which would be 9/2 plus 4/2, so we would have a negative value here. You can check it yourself. If we plug in a -3/2, we would have a -3/2, so this is negative. Plugging in a -3/2 plus 1, and 3/2 is bigger than 1, so a -3/2 plus 1 is -1/2, so I have a negative. And a -3/2 here is not as big as 2, so this would be positive. So our p of x would then look like this. We would have a negative number on top, that's the 3x plus 2, divided by a negative times a negative times positive. And this result will be, I'm going to do the result in red. This result will be a negative number divided by a positive number. So negative times negative is positive, so we'd have a negative numerator and a positive denominator, so we have a negative number here. Now for checking between -1 and -2/3, we can use -9/10. This will be a negative number still. You can check these yourself. -9/10, of course, makes this negative. -9/10 will make this positive. And -9/10 will make this positive. So we would have a negative in the numerator, a negative in the denominator, and 2 positives in the denominator. So we would end up with a negative divided by a negative times a positive times a positive, which is going to be a positive number. You have a negative numerator, a negative denominator, that gives us a positive. And now between 0 and -2/3, -1/2, -1/4, something like that. -1/4 will make this positive. -1/4 will make this negative. -1/4 will make this positive. And -1/4 will make this positive as well. So here we have a positive divided by a negative times a positive times a positive. So we have a positive numerator, a negative denominator, and that gives us a negative overall. So p of x is negative on this interval. Okay, last one, if x is bigger than 0. If x is bigger than 0, you can pick 1,000, anything that you really want. That will make this positive, this positive, this positive, this positive. So we end up with a positive, the 3x plus 2 is a positive value, divided by a positive times a positive times a positive, which gives us a positive number. So this polynomial, p of x, is positive on the interval when x is bigger than 0. So the question then becomes, which of these intervals satisfies this inequality? We're looking for when p of x is less than or equal to 0. What does that describe? Positive or negative numbers? Well, if we're less than or equal to 0, then we're talking about negative numbers. And 0, of course. So I look here at p of x and I look for all of the negative intervals. These are going to be a part of the solution set. So I'm going to write my solution set out, and then I'm going to ask you a question about it. So the solution set I come up with is -2 to -1 union with -2/3 to 0. And this is my solution set. So now my question is, why don't I have brackets everywhere? We have less than or equal to, right? Why are there not brackets around the -2 and the -1 and brackets around the 0? Why is my only bracket -2/3? Definitely pause the video and think about that. Please think about it for a few seconds, at least for a minute or two. Now, when you unpause the video, the answer is because -2/3 is in the numerator. When we have a denominator value, that does not equal 0. So let's assume that -2 is a part of the solution set. This would mean that I would have a bracket here instead of a parenthesis. So if I plug in -2, then I would be dividing by 0. That's outside the domain of the expression. So I can't divide by 0, which means I cannot include -2. Similar, I can't include -1 because it also makes the denominator equal to 0. But what I can include is -2/3. -2/3 is the cut point that comes from the numerator. So if I plug in -2/3, I get a 0 in the numerator, which is okay. So we would have 0 divided by a non-zero number in the denominator. And that's fine. That's why I can include -2/3, but I can't include the other values. So even 0, making the first point in the denominator equal to 0. So this is your solution set. You have to be careful when you're working with these problems, because there will be very tricky problems where you include some points that you wouldn't expect and you exclude some points that you don't expect. I want you to try one now. Find the solution set for the rational inequality x minus 3 divided by 2x plus 5 is greater than or equal to 1. Be careful with this one. Just because there's a constant number over here does not mean that you can leave it over there. Remember the very first step. We have to get everything on one side so that we have a 0 on the other. That's going to be it for today. I will see you all in the next lecture.